asking about this, since we don't have everybody here. I'm going to go ahead and record what I'm talking about now. The actual process of going through. So I have my fake t number here. It told me to use sample set 4, and it gave me the temperatures. So my first task is to figure out, is my reaction 0 first or second order? So I'm going to, and the exact way that you do this isn't terribly important. As long as you have, by exact way I mean like you don't have to make space in between the columns here. You could put your columns out here. I just prefer to have all my data right next to each other. So I'm going to make this one the natural log of absorbance, and I'm going to make this one 1 over the absorbance. Because again here, that the 3 graphs that I'm going to make are absorbance versus time. That one will be for 0 order. Natural log of absorbance versus time. That'll be for first order. And then 1 over the absorbance versus time. That is second order. Absorbance is a stand-in for concentration here, which is perfectly fine to do. Concentration and absorbance are directly proportional, so it's perfectly fine for us to go ahead and just plug in absorbance instead of concentration. So, because I don't want to do all that math on my own, because there are, let's see, 300 data points, I do not want to type natural log of something into my calculator 300 times. I'm going to say, hey Excel, we're doing math, so I'm going to put an equal sign in there. This is equal to ln, the natural log, open parentheses, that cell, close parentheses, enter. And so it does the natural log for me, and then because I don't want to click and drag, I will just double click on that little square in the bottom right corner. It does all the rest for me. And so you can see there that it just goes all the way down until the data stops. So I'm just going to do the exact same thing here. Equals. Now it's going to be 1 over instead of the natural log. Oops, not that one, this one. Don't do what I just did. You want to have 1 over the absorbance, not 1 over the natural log of the absorbance. So, go, double click. Okay. So now, I am going to, and actually, well, let's see if it works. It might work. I'm just going to go ahead and select these 2. I don't know if it's going to, it might get angry with me for including those titles. I can just delete them if it does. That might be okay, actually. So if you didn't catch what I just did there, I clicked and dragged on the A and the B at the top there, and so it just selected the whole columns. And then I did insert, scatter, and just that first one there. And I think that it is actually plotting it correctly. I don't think having the titles is messing it up, but we'll see. So I need to just do the same thing again, so I'm going to go ahead and rename this real quick. So this would be 0 order. So I'm just going to do the same thing, but now I'm going to do it with the first order, which would be the natural log. So time natural log. And again, to select things that are not right next to each other, where you can't just drag and select, you're going to hold down the control button, at least on a PC. I don't know if Apple is different, but on a PC you hold down control, and that will let you select more. Okay, so just the same thing again, insert, scatter. Alright, I think that is okay. we'll do the last one here. Okay, so this one is first order, and this one is second order. So we have our three graphs. To determine the correct order of the reaction, we are going to put a line to the data. And so to do that, you can just right-click on any of the data points, add a trend line, and then display the equation and the r-squared value. And again, the lab talks you through doing most of this stuff here. So I'm not going, and we've done it before, so I'm not going to belabor it too much. I'm just going to relatively quickly put some trend lines on here. So we have our data with our three data sets there. Let's see, questions coming. Yes, it does assign you. So if I were to go in here and change this t number to something else, it would most likely tell me a different sample set to use. So this one told me to use 4, and so that's why I'm over here using a data set 4. By the way, when you turn in this lab, please, dear God, please, delete all the data that you don't use. So either if you're using this file and you just do the work in the file, delete all the data sets that you don't use. Or alternatively, take this data and copy it into a different Excel file and have that be the one that you turn in. Please do not turn in a data file that has all the data sets in it. That is the worst thing for me to grade, because I have to just search and search and search to find your graphs and your data. It is just incredibly annoying. Mainly just because of the way that it's displayed when I grade it. Like it can see Excel files, I can see them and I can read them, but when you have 8 whole data sets like this, it's just pages and pages of just numbers, and I'm like, okay, well, I don't want to see just the numbers, I want to see the graphs. The graphs are the main thing that I'm looking for. So please, either move your stuff to a new file where it's just the stuff that you're turning in, or delete the stuff that you don't need here, because it is such a pain. So scroll, 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 and be searching for your data in Blackboard when I'm trying to grade it. So please only use the stuff, only turn in the stuff that you actually use. Let's see. So when we have our graphs here, our 3 graphs, the one that is telling us the order of the reaction is the one that has the r-squared value closest to 1. So you can see here, none of them are way far away from 1. None of them are like 0.5 or anything like that. But they're clearly not straight lines. So there's clearly a curve here, and there's clearly a curve here. This is clearly the most straight line of the 3. And so this tells us that our reaction is first order. And so, let's see, I think that's all I want to go into on that, just because I don't want to just tell you how to do everything in the lab. I do want you to work out a few things. The lab does just tell you some stuff as well. But the last thing I want to go over in this over the lab is doing the Arrhenius plots. So for the Arrhenius plots, what you're going to do is you're going to need the K values for all three of the temperatures at which you did the experiment, which means that you're going to need to have the graph for each of those temperatures. So in my case here, the reaction was first order. So what I would do is I would take the second and the third trials, and I would make another first order graph for those as well. I would not bother with making a zero order. I would not bother with making a second order because the reaction isn't those orders for me. So I would only do first order for the second and the third, and I would get the K value from the graph, and then those K values are what I'm going to plot. So the Arrhenius graph is going to be just 3 data points. It's like the exact opposite of the graphs that we have here. These graphs have 300 data points. Our Arrhenius plot is going to have 3, just 3. Because if you remember, the Arrhenius equation gives us, let's see, actually, can I remember? I believe it's 1 over the temperature and the natural log of K. I believe those are the what we're going to be graphing. So you're going to have K values that you're going to take the natural log of, and you're going to have 1 over the temperature in Kelvin. It's another really important thing. Do not forget to convert to Kelvin. That's a relatively common mistake that students make, is that they will just take the temperature as it's given. Normally, when we're measuring temperature, we measure it in Celsius, but we need the temperature in Kelvin for our graph. So you will have 3 data points. That's it, no more than that. And those 3 data points should give you a straight line. And so from that straight line, then you can get the activation energy and the frequency factor. And if you're unfamiliar with how to do that, you can go back to chapter 12 and watch the videos where I do that. I do that in at least one of the videos. I pull the activation energy and the frequency factor out of a graph. Okay. I think that is all I wanted to talk about for the lab. Are there any questions about the lab? Okay, so just to reiterate here, at the end of the lab, and I would prefer it, it's not required, but if you want to keep me in a good mood, I would prefer it if all of your answers are very clearly marked, and preferably kind of all together, so I don't have to go searching for them. But you need to tell me what is the order of the reaction. You need to tell me the rate constants, which, I mean, you have to find those to get the Arrhenius plot. But you need to tell me the order of the reaction, the rate constant, the energy of activation, and I believe it asks you to find the frequency factor as well. I think it does ask for those. Yeah. Calculate the energy of activation and the frequency factor. So please have those relatively easily found in the file, and then have your graphs as well. So I need to see all of the graphs that you make. So that should be 6 graphs, because you have 3 for the first trial where you're figuring out if you have 0 first or second order. So you have those 3. You'll have the second trial and the third trial, which will only be 1 graph each. Once you know what the order is, you'll only need to do 1. And then there'll be the Arrhenius graph. So that's 6. So if you have all of that there, that's all I need, is those graphs and those specific sets of information, the K values, the order, energy of activation, frequency factor. I do not need all of your actual raw data. If for some reason, if I feel that something is hinky, if I'm like, I don't really think that's their data, I think they just made something up, or they got it from someone else, or something like that. Like if I feel like I need to go back and check your data, which I have done multiple times in the past with other classes, I have access to your T number, I have access to the same file that you do. I can just plug your T number in and get your actual data that you should have used and see if it matches. I have had, there was one time in the past actually where a student used data that was not their data, and I don't think it was done intentionally. I think it was just it was an inadvertent mistake. But I can do that. So I don't need your raw data. I don't need all 300 data points for all that stuff. I just need the graphs and then that specific data. I'm not going to take points off if you turn in those, but it won't make me happy. If they're for chapter 13, yes, or for Thursday, yes, we're staying in chapter 13. So the videos for this week go nearly to the end of 13. So I think the only topic in 13 that you're not supposed to get to this week is Le Chatelier's principle. So yeah, we'll stick with chapter 13 for Thursday. And there's plenty there. There's plenty for you to go through. Thursday, unless there's more questions about the lab, which is possible, I will probably spend most, if not all, of the day Thursday, or all of our time on Thursday, doing equilibrium practice problems. Because just like what I said, it is the hardest math that we're going to do this semester in this chapter. The acid-base stuff that we're going to do in the next chapter is, in terms of the math, I think anyway, a little easier. It's still not super easy, but it is easier than what we're doing in this chapter usually, mostly just because the acid-base balanced equations are generally pretty simple, and some of the equations in this chapter are simple and some of them are a little more complex. So the more complex the balanced chemical equation, the harder the math is to solve it, just because you have to deal with all those crazy powers, and so the math just gets funky when you do that. So yes, we will stick with chapter 13 for Thursday and probably just do some practice problems. Other questions? If there are no other questions, I think I will go ahead and let you all go. We made it through, didn't lose power. I say that and it's going to cut right there. That would have been hilarious.